highlighted, right? Similar triangles that are the same shape, but different sizes. And so today we're going to talk about finding some unknown sides in similar triangles. And instead of using like proportions like we used yesterday, we're going to use something called geometric mean, which essentially still is just more proportions is all we're really doing today. So it's very similar to what we did yesterday. It's just a new way of looking at our triangles. So first part there says the geometric mean of two positive numbers a and b is the positive number x that satisfies or that follows along with the equation that is a over x equals x over b. A over x equals x over b. So geometric mean is just the number that when I multiply any two other numbers before that I can solve for x. So when you have two fractions, just like what we did yesterday, when you have two fractions, you're going to cross multiply your two fractions, okay? So if I were to cross multiply my two fractions, what is x times x? Oh, x squared. And then what is a times b? It's just ab. Yeah, so it's any number that it is, you're just essentially multiplying those two numbers together. So in a moment, we're going to plug in two numbers over there, right, for a and b. But essentially all you're doing is you're multiplying these two numbers and you're multiplying these two numbers. Now, if this was an equation here, x squared equals a times b, how would you get the x by itself? What's the opposite of squaring something? No, it's not dividing. It's square rooting, yes. So if I square root that side, I'd have to do the same thing over here. So if I take x by itself, that's the same thing as the square root of a times b. Okay, so I'm going to show you what that means with these examples here where we're going to find the geometric mean. So these two numbers, the first example, 45 and 5, this stands for your a value and your b value. So I'm going to take those two numbers and I'm going to plug them into this equation right here for a and b. So what would my first fraction be? What divided by what? 45 divided by x equals, and then what would my other side be? X over 5, my second number. And so now I'm going to cross multiply. I'm going to solve for x. So just like I did before, what's x times x? X squared equals, and then what's 45 times 5? 225. So now I just have one step left to get the x by itself, which is to do what? Square root it. So I'm going to square root the left. I'm going to square root the right. So x is the square root of 225. That means what number times itself gets me to 225. So we're going to practice putting that into our calculators. Do you guys know how to put that in your calculator? Have you done it before? Okay, so there's two ways. If you have an actual calculator, right, like from the back that you grabbed, what you would do, so everybody look up at the board, if you have the real calculators from the back, you're going to put the number in first, 225, and then you'll see the square root symbol right above the x squared. You see how it's in yellow up here? If you want to touch anything that's yellow with your calculator, you have to push the shift button first. So I would push shift square root, and it gives me my answer of 15. That means 15 times 15 gets me to 225. So that's how you would do it on the calculator. Now, if you're using it on your phone, if you have a iPhone, it has to be off of, the orientation has to be unlocked. So when you go to your calculator, I'll show you. So you have to be able to turn it sideways, and a whole bunch of other stuff is going to pop up. So it has to be unlocked, because if it's not unlocked, when you go to turn it over to the side, it's not going to pop up for you. Okay. And now if you're going to do it with your phone, again, you put the number in first that you want to do. So you put 225. And then the button that is the square root is this one right here. It's got a square root with a little 2 next to it. Be careful that you're pushing the right one. So above it is x squared. Underneath it is the square root, the one with the little 2. So you would push that button, and then again, your number there comes up as 15. And a good way just to check, just to make sure you're right, is if I did 15 times 15, I should get 225. I'm fine. Does that make sense? Okay, so let's do a couple more examples, same sort of thing, geometric mean. My next one is 6 and 24. How would I set up my fractions? Beautiful. 6 over x equals x over 24. And again, it's the exact same setup. I'm going to cross multiply. So x times x gives me x squared. And what's 6 times 24? 144. Good. So now to get the x by itself, I do what? Square root. Okay, so everybody put in your calculator. Let's make sure we get the same answer. I want everybody to practice it. When you're square rooting, also your number should get smaller. So if you get a bigger number, you push the wrong button. What did you get? 12, right? So 12 times 12 gives me 144. Yep, I'm good. Easy stuff, right? Okay, do the last two, and let's see if we get the same answers. 412 and 1545. Try those two. You are going to get some decimals, so don't freak out. Yep, don't freak out. They're not going to be perfect. Okay, so for the first one, you should have gotten x squared equals 48, right? And then you put the square root of 48 into your calculator, and what did you get?
6.928.
Yep, 6.928. You can put 6.9. Doesn't really matter. But when you write, bless you, when you write your answer, make sure you put the approximate symbols. So it's not equal because we're rounding. It's approximate. That's why they're like the little squiggly ones. So about, I'm going to put 6.93. Round to 2 decimal places. But if you put 6.9, that's cool. And then what about on the right side with 15 and 45? What is the geometric mean of 15 and 45? Approximately. 25.98. Very good. So again, about 25.98. And if you just put, if you put more decimals, less decimals, I don't really care. I didn't tell you what to round to. So just round to the best of your ability. Okay, not too bad, right? Geometric mean. So now what we're going to do is we're going to take that idea of geometric mean and we're going to apply it to some triangles, to some similar triangles. And our similar triangles are going to be right triangles, all of the triangles. So go ahead and open up the little flap here. We're going to start on the left. Okay, so there are 2 different theorems we're going to talk about. The first theorem is the altitude theorem. So this theorem says the length of these, so take your first color, whatever your color is, The length of the altitude is the geometric mean of the lengths of the two segments. So in my picture here, you've got a right triangle, and you've got this really big right triangle right here. You also have two other smaller right triangles on the inside of it. So I'm dividing up the big right triangle into essentially two smaller ones on the inside. So there's 3 triangles in total in this picture. The small one on the left, the middle one on the right, and then the big triangle in total. The altitude is the piece that splits your triangle into the 2 smaller pieces. So in this picture, my altitude is this x right here. This is the altitude. So altitude essentially means height, and so that altitude is the one that's splitting that triangle into those 2 smaller ones there. So to find the length of this altitude, I'm going to find the geometric mean of the, 2 segments that are left over here. So to find the geometric mean, it's essentially the exact same setup as we just did. I take one of the segments A, I divide it by the altitude, which is x, and then I take the altitude over here, that was x, and divide it by the other segment. So what you're going to notice is your x's should always be diagonal, and this is the exact same equation as we had on the front. Literally, exactly the same. So your altitude, this highlighted piece here, should always be diagonal to each other. So this piece is your segment. This piece is an altitude. This piece is your altitude. This piece is your segment. So essentially, we're just making 2 fractions with our side lengths. So let's take a look at number 1. We're going to use this theorem to find x. So the first thing I'm always going to do is I'm going to highlight my altitude in every single problem that I do. So in number 1, which piece is your altitude? The 2, the x, or the 50? The x. The x. So let's highlight our altitude. All right, and we're going to set it up just like this one is over here. The segment divided by the altitude equals the altitude divided by the segment. So here are my pieces. Here are my 2 segments right here. Here's my altitude. How do I set up this equation? What do you think? Two over x equals, exactly. So these 2 pieces right here are your segments. That's a segment. This is a segment. So I take one of the pieces, divide it by the altitude, which is x. So 2 over x equals the altitude divided by the other segment, x over 50. And again, I want to make sure that my altitudes are the ones that are diagonal, which they are, so I've set it up correctly. Now it looks exactly like the ones on the front. I'm going to, because I have 2 proportions, I'm going to cross multiply. So just like the front, what is x times x? X squared equals, what is 2 times 50? 100. 100. Okay, to get the x by itself, I do what? Square root both sides. So x is equal to what? So what number times itself gets me to 100? 10. So there you go. You have figured out the unknown side length by using geometric mean. All right, let's try the next one. Same setup. I'm going to start by highlighting my altitude. Which one in this picture is your altitude? 18, 10, or x? The x again. So highlight your x. Okay, now I need to figure out my 2 segments. so my two segments are the two smaller pieces, but I've got a problem. What's my problem? Jasmine? I've got the one segment is 10, but I don't have this segment over here. However, I know the whole thing's 18. What does that mean this piece has to be? 8. Beautiful. There's your other segment. Now let's circle our two segments and let's write our proportion. So our proportion should be segment divided by the altitude, altitude divided by the segment. So what would my proportion be for this problem? 8. Wait, sorry, say it again. 8 over x equals x over 10. Beautiful. And again, I want to make sure that my altitudes are diagonal. Boom and boom. They are, so notice I always highlight. And then now from here again, it's easy cross multiplication. So x times x gives me x squared. 8 times 10 gives me 80. And then now I just have to take the square root. That's going to give me a decimal. 8 point something, right? What is it?
8.94.
8.94. And again, because I'm rounding, I'm using the little squiggly lines because it's not equal to, I'm saying it's approximately 8.94. Good. Yeah. All right, so questions so far? Feeling pretty good. Not too hard yet, right? Okay, let's take a look at number 3. Now, don't forget, still the same setup. You've got two segments, you've got an altitude. This time, which one is your altitude? 6. Okay, highlight it. Which one are your two segments? 8 and x. So now this time, when I write my fraction, I know for sure, right, that my altitude has to be here. And I know the other two pieces have to be my segments. What is my fraction going to be for this problem? 8 over 6 and 6 over x. Beautiful. Good, good, good. Now, we're still doing the same thing. We're going to cross multiply. It's just going to be a little bit different this time. So, what is 6 times 6? Equals, what's 8 times x? 8x. And so now this is just an algebra problem. What do I do to get x by itself? Thank you. Divide by what? 8, yeah. Divide by 8 on both sides. So you're going to get a decimal, I think. What do you get? 4.5 is your x value. Beautiful. Okay, you try number 4. Let's see if we get the same answer. Give number 4 a try. Highlight your altitude. Set it up the same way. All right, what did you get for number 4?
It's approximately 2.08.
2.08 or 2.083. something of that nature. Miss Master just realized she made a mistake because she should have put an approximate sign with the squiggles, right? So if you didn't, just draw over it, right? Because it's not a perfect number. So anytime you're rounding, you got to make those little squiggles. Okay. How are you feeling?
Good.
Feeling okay? All right, now we're going to do one more theorem, and this time we're going to use the other two colors. So that color you just used, you can push it off to the side. We're not going to use that one anymore. That color is your altitude color. Now we're going to use two more colors for the second theorem. So my second theorem is hypotenuse leg. First of all, what's the hypotenuse? Who remembers? Or like, where is it located? Where with the right angle? You're like on the right track. Let me think. Lauren's like doing this. She knows what it is. What do you mean the leg? So in a right triangle, you've got like the right angle. Then you've got the side that is across from the right angle. It's the longest side, the biggest side is your hypotenuse. So we definitely above hypotenuse. We need to write it is across from the 90 degree. Across from the 90 degree. So in this theorem, it says the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So hypotenuse means you go to the 90, you go across from it. The other two sides are called the legs. So in this picture here, we've got the really, really big triangle, A, B, C. So take one of your colors. Let's highlight the big triangle. Okay, and we're going to add in two numbers here just so we can write the equation. So over here by AB, we're going to add in the number X. At BD, we're going to add in a 2. And at DC, we're going to add in the 8. So you've got some little pieces here. Okay, now looking at that whole big triangle in the pink, I'm going to take the hypotenuse and divide it by one of the sides of the leg. So if you're looking at that big pink triangle, which side is the hypotenuse? Which one? I don't know if I agree with that. BC is the hypotenuse, right? Because here's the 90 degrees. If I go across from that 90 degrees, boom, it's this whole side. So I'm going to take BC and I'm going to divide it by the other side of the pink triangle that has a number. Which other side of the pink triangle has a number or a letter? AB. Right over here has the X. So I'm going to take, this is the hypotenuse, and I'm going to divide it by this leg over here on the side, which is AB. I'm going to set that equal to another hypotenuse and leg of the smaller triangle that contains this X value. So with your second color now, we're going to highlight the other triangle. So there's two more triangles. The one that has the X is this one on the left. So it's this little baby blue triangle over here. If you're looking at this blue triangle now, just the blue triangle, which side is the hypotenuse of the blue triangle? AB. And what's the other piece of this blue triangle that you know? Which one has a number? BD over here. Now notice something. Your hypotenuses, look, do you see how they're diagonal from each other? They should always match. Whatever this is, this should always match. Notice that those two match up. The other two don't. So when you're writing your equations, they have to match up. That's what geometric mean means. Okay, so let's take a look. We're actually going to do 7 first, then we'll go back to 5. So jump down to 7. Put the wrong ones in the wrong place. Okay, take your first color. That's your big triangle. Highlight your big triangle, ABC. Okay, we're going to write an equation that says divide the hypotenuse by the leg of that pink triangle. So which side again is the hypotenuse of that pink triangle? It's the same as up above. Which one was the hypotenuse? B to C. B to C. Now, what is this whole length of the hypotenuse? 14. How'd you get 14? Good, you added the 2 together. So my hypotenuse of the pink triangle is 14. What's the other side of the pink triangle that you know? So you've already used this side. What's the only other side that you can use? Which one? Yeah, this one with the X right over here. This is your other side. Just say it. There's your pink triangle. There's your first piece. Now, we're going to set that equal to the hypotenuse and leg of the triangle that has the X. So the triangle that has the X is this one on the left. My blue triangle over here. And I'm going to do the same thing. I'm going to do the hypotenuse divided by the leg. Now go to that blue triangle. Which side is your hypotenuse? Give you a hint. Yeah, these have to match. So your hypotenuse has to be X. What is the only other number you know in that blue triangle? 2. Right over here. So here is your equation. Doesn't that look exactly like what we've been doing? Yes. So we're going to cross multiply. What's X times X? What's 14 times 2? 28. And now I take it and I square root it. I don't know what that is. You get X is approximately 5.29. And that's it. So the only hard part here is just making sure you set it up correctly, but your diagonals should match. No matter what it is, they should match. I'm sorry? Yeah. Okay, now let's jump back up to 5. Actually, do I have any questions on that one? Okay, let's jump back up to 5. Let's redo this one. Again, you've got your big triangle. You're always going to use your big triangle. So let's start by highlighting my big triangle. Notice I'm doing the same thing over and over and over again. Okay, my big triangle is in pink. I'm going to do hypotenuse over leg of the pink triangle. So, looking at my pink triangle, which side is your hypotenuse? BC. Good. What is the length of BC? 16. Great. There's your hypotenuse. What's the only other leg you know of that pink triangle? X. So it's 16 over X. There's your first equation for the pink triangle. Now, I need to pick the triangle that has the X with it. So am I going to pick the triangle on the left or the right this time? The right triangle. So this time I'm looking at this one over here because it has the X. So I'm looking at this one. Okay, now I'm doing the same thing. I'm doing hypotenuse over leg. Now remember, you're doing geometric mean. Your diagonals need to match up. What's the hypotenuse of this blue triangle? It's X. Yep, directly across from this 90 right here is X. And I noticed that my X's are diagonal, so I'm good. What's the only other leg of the blue triangle that you know? 4. There's your equation, or your proportion. 16 over x equals x over 4. All right, same thing like I did before, we're going to cross multiply. X times x is x squared. 16 times 4 is 64. And then what's my final step? Square root it. What do you get for your x value? 8. Wonderful. You figured out your unknown side using geometric mean. Okay, you're going to try number 6. Just like how we did it, exactly the same. Give number 6 a try. Let's see if we get the same thing. I'm sorry? What did I say? Oh, I'm a poet and I didn't know it. Ta, 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 ta. If you get that one done, you feel like you're ready for like a real challenge. You can do 8 and 9 as well. Give you one more minute. All right, who's gonna walk me through the problem? Who's gonna do it? Oh my gosh, Stephen, go for it.
So the hypotenuse thing is 45.
Okay, hold on. So first triangle, big triangle, pink one. What's your hypotenuse?
45.
How'd you get 45?
20 plus 25.
Beautiful. So you have to add the two segments together to get the whole thing, 45. Okay, what'd you do next?
And then put X and the number.
Okay, good. It's the other number in the pink triangle. Good. All right, then what?
Then I went to the other triangle.
Which one? The one on the left or the right?
Right.
Why?
Because it has
It's one that has the X with it. Good. Okay. So here's your blue triangle. What was your setup for the blue one?
X
Over?
25.
Beautiful. Okay, and then keep going.
X times X is X squared, and 45 times 25 is 1,125. And 1,125 square rooted is 33.54.
And it's approximate, right? Okay, approximately, and it was what? Say that again?
33.54.
33.54. Wonderful. Good job. Okay, so you always use the big triangle to start, and then your second triangle choice is always the one that has the letter that goes along with it. Fantastic. Okay, how are you feeling? Should we give me a 1 to 5? How are you feeling? 5 is like, oh my God, this is the easiest thing ever. 1 is like, oh no, I don't know. How are you feeling?
Well, no.
Oh no, oh no. Okay, hey, a lot of 3s and 5s. I'm into that. That's fantastic. Okay, are you ready to do a tricky problem?
No.
You ready for the tricky ones? As hard as it's going to get right here. Because in number 8 and number 9, what's a little bit different about these two problems? Ha ha! I gave you an X and a Y. Mr. Massa was evil. I gave you two things to do. So let's take a look. Let's do number 8 first. All right. Now, tell me something that you notice other than the fact that there's an X and a Y. What else do you notice about it? Letters are different. Okay. It's what? Oh my gosh. What's an altitude? Which one of them? Oh, this one's got an altitude and I've got some numbers on the outside, which means you're going to have to do both theorems in one problem. Oh gosh. All right. So let's do the altitude first. Altitude's an easy one. Which one is your altitude? 8. Okay. So remember, go back to your altitude color, whatever color you used on the left. Go back to that color. Altitude. Let's highlight our altitude. Oh, Lord. Wild. Mr. Ass is making you do so much work. Gosh. Okay, now remember, when you do the altitude problems, it is a segment over altitude, altitude over segment. So it's the two pieces of the hypotenuse. The two pieces of the hypotenuse. So come over to the picture. Which are going to be the two pieces I'm going to use for my segments? Yeah, 6 and Y. Okay, so here's my segment. Here's my altitude. How do I set up the equation? Remember, diagonally, your altitude should match. So this piece and this piece should be your altitude. Right? Notice that I always highlight like that still to this day to keep me like whew, in the right spot. So what would my equation look like? Beautiful. 6 over 8 and 8 over Y. Okay, and then it's some algebra. So this was the altitude. All right, so let's cross multiply here. What is 6 times Y? 6Y. Equals, what's 8 times 8? 64. What's my last step to get the Y by itself? Divided by what? 6. Good. Think you get a decimal. 10 point what? 6, 6. Okay, I'll put 10.6 repeating. Ta-da! Good job. You figured out one of the pieces. That wasn't too bad, right? So if you want, you can put 10.6 repeating right there. 10.67, 10.66, whatever. Okay, you did it. You got the altitude. Boom. Beautiful. Now, altitude's done. We're going to go back to hypotenuse leg to solve for x. So first thing I should always do is go to my big triangle. So take your color, whatever your color was for your big triangle. I'm going to highlight my very large triangle here. Okay, now be so careful. When we do these triangles, remember we do hypotenuse over the leg. Hypotenuse over the leg. I'm not going to have enough space there. Hypotenuse over the leg. So for my pink triangle, what is your hypotenuse? It's what? 16.6666666, right? It's this whole length, so I have to add the two together. So I'm going to round it to, oh my gosh, we have like one more minute. 10.67. Ah! What's the other leg of the triangle? Oh, we already used this. X equals x over, what's the only other number? If you're looking at this triangle now over here. Yeah, x over 6. Okay. Your homework tonight is number 9. Okay? Yeah, finish up that one part and do number 9. Okay? That's your homework tonight. Good job, my dears. We'll check it tomorrow. You guys did fantastic.
What we did on Tuesday.
It was, yep, that's the one.
Can I borrow a crayon?
Yes, you can, as long as you bring it back to me.
I'll probably give it back to you.
That's fine. That's fine.